Okay. So, that is what we said, that carbon dioxide emission is a major problem. So far to our understanding, this is the only planet which has got life, and it is because of delicate balance between carbon molecule and atom with the rest of the atoms and molecules. Polymers, everywhere you have, C is the main thing. Living matter and dead matter are transformed into each other with its natural flow, but if you disturb that flow, there is a problem. So carbon is very important from that point of view. So therefore, what should you be doing? 4 important threads: reduce, reuse, reduce resource consumption, whatever you are taking from Mother Earth, recycling, and recover as much as possible, right? Re-engineering the material that we use, so reuse sort of, changing the molecule flow using non-fossil fuel energy if there is a possibility, right, using non-fossil fuel, and then realizing sustainability is a good business and realizing that this is important. Okay. So, with this we can actually reduce the impact on environment, impact of technology on environment. With this kind of understanding, these 4 principles if you look into, then we can. So, this is 4 R's actually: reduce, reuse, recycle, recover. Then re-engineering, changing molecule flow using non-fossil fuel energy, like various kind of being attempted, solar energy, wind and things like that. And then you must realize that sustainability is a good business thing. So, it is a goal. Now, I will define this. What is the goal? The built environment offers enormous opportunities for re-engineering, right, and improving sustainability. Reuse, re-engineer the material. By re-engineering material, we can reduce the volume of take from the waste. So, whatever is waste, if you can reuse it, re-engineer the same thing, then we are reducing down the volume of waste production. The technology paradigm define what is or is not a resource in an economic system that drives material flow through the techno-process. Okay. If you see the civilization, many materials were there for millions of years. Nobody used them because they did not know how to use it, right. Gradually, human being learned to use, let us say, coal and materials like iron, right, Iron Age and so on. Silicon was not at all, I will just digressing a little bit, silicon was not at all so much of an important thing, it is so much there in the earth crust. It is one of the, after carbon, silicon will be abundant, right. That is the material which is abundant in the earth crust, and that material was not so important till possibly semiconductor came into being, right. It was a transistor 1950s, 48 around that, John Bardeen, Maclay and somebody, there are 3 scientists in Bell Laboratories. They came out with this semiconductor. So semiconductors are silicon, germanium, etc., etc. And these are the ones which becomes very useful. And a corollary to that, very interesting, is since silicon came by, I do not know whether I have mentioned this in some other class or something, silicon came by, they wanted to produce silicon, ferrosilicon alloys or silicon, they started producing what is called condensed silica fume, because they will heat up quartz to produce, quartz will be heated up to produce silicon metal, and in the process very fine fumes comes out of silicon oxide comes out. So, this is a fine material and that is condensed silica film, extremely reactive with lime, and that is what has led to production of high strength, very high strength or reactive powder concrete. You would not have any concrete of 100 MPa strength, but for semiconductors, because so silicon was very much there, nobody realized it is important so much till possibly semiconductor came into being, and today all of us are carrying lot of it, everybody carrying everything, lot of semiconductor solid state stuff all over there. So that's the thing. So therefore so resources goes on change, you find out new resources. So what is not a resource in an ecosystem drives the material through the techno-process. So silicon was not in the techno-process, it came into techno-process, and by basic human psychology through cultural change achieve greater demand of, obviously you should demand for more sustainable outcomes, and delivered by evolving changing techno-processes. So we should look into techno-process changes as that so cost effective solutions, economics, that should define sustainable resource flow, material resource flow. So we can define now sustainability. It is the capacity to endure or support, that is how it has been defined. Capacity to endure or support such that sustainable materials shall meet the current needs and requirements without compromising with the ability of future generation to meet their own needs. You satisfy your own needs, but it should not have any impact on need of the future generation. Do not consume all the resources from the mother earth, so that your planet equivalent is 2. So you are using whatever been stored previously, and future people may not have been, they may not be, nothing resources should be available. So sustainable materials uses the resources like energy, the material itself, and water with increased efficiency for production and induction, while reducing impact on human health and environment during the life cycle up to demolition and disposal and recycle. So two aspects. First, it must use the resources with higher efficiency, maximum benefit out of the resources that you are using, and also minimize the impact on environment, human health and environment during the cycle up to its demolition or disposal or recycle. So that is what defines sustainability and sustainable materials, that is what it is. Sustainable development then would follow automatically. For example, an sustainable urban system would also minimize the use of resources, water, etc., produce least waste, and keep the atmosphere harmless. 3 pillars. Sustainability is supposed to have 3 pillars, right? Environmental is one of them, and the social aspect is also important, and you cannot really get away from economy. So these are the 3 pillars of sustainability: environmental, social, and economic pillars, right? Socially also it should be acceptable. Socially also it should be acceptable. Not only it should be acceptable, the society itself should be sustainable, right? So that's what it is. So using natural resources, material, energy, water without affecting the need of future generation, that's what we said. And then comes the green concept, which goes together with it: low carbon, good air quality, recycled material, reduction of waste, and generation and efficient handling of the resources. So we have defined sustainability, we talked about sustainable pillars, etc., and the green concept goes together with it. So they go hand in hand, that is what it is. Whatever is sustainable is green. Whatever is sustainable is green. So should have low carbon emission, air quality, better recycled material as much as possible, reduction in waste and generation and efficient handling, etc., So development that meets the need of the present generation without compromising the need of the future generation is what is sustainable development. That means living within the means of the planet, right, living within the means of the planet. So, reduction of impacts of our activities on Earth system, that is what we should be looking at, and in that context life cycle assessment becomes important, right. So, what we call cradle to grave for any material or system. So, you should look into during, when you are looking at sustainability, we cannot avoid looking into what is happening in during the life. One is the production part of it, making it, then while using also it should not generate waste, it should not generate, for example, a system like building, let us say. A building when it is in use, after all it is for human habitation, there may be many functions, functions, for example, this is a classroom, its function is to hold the class, and it can generate waste in the process, consume resources like energy and so on. So, life cycle assessment looks into the whole thing, whole life of the system, or even for a material or anything you want to see for a component even. For example, your computer, if you look at it during its life period, it may use some energy which is very minimal, but then later on when it is to be disposed of, electronics waste, how does one dispose of, and all these things has to be taken into account when we look into life cycle assessment. From the mother earth to demolition or disposal, that is what it is, from mother earth. So, cradle to grave is this kind of terminologies are used, and somewhere the waste and pollution generation should be minimal, right, at every stage. So, that is why the life cycle assessment is important. So, life cycle assessment is important, that is why the life cycle assessment is important, right. So, in the context of we looked at everything. Now, if you look at energy, there are certain types of energy. Just let me first come to this. Oh no here. Let me, okay, next class possibly we will talk about, but life cycle energy we should look into. The energy is classified into, you see, some of them are primary energy and some of them are secondary. Electricity, for example, is a secondary energy, because you either use some other energy, convert into electrical energy which can be used efficiently. So, that is secondary. So, some definitions I will give you later on, but there are some other issues like something we call embodied energy. Now, this energy is the energy that has gone in when it came into the system, a material or system, when I have produced it, how much energy has gone into it. So, this would encompass production energy, energy for production. So, give an example of, if I take concrete or steel, let us say, the materials that we use. Now, energy of concrete, first there is a component, the cement is there, the proportion of the cement. Now, if you see the process of production of cement, which we will look into sometime again, it starts from the quarry, right. They select the limestone quarries with appropriate proportions of lime and silica, because cement is produced from this plus this, this SiO2, clay or Al2, etc., etc. Some of them come from the process itself, because this is more from clay, I will say, clay, right. So, you start from quarry. From the quarry you collect the rocks, the material. It is minimally processed, because you do not want the cost to be increased, but it is homogenized. Homogenized means mix up from here and there, do quartering, take something from here, take another place, mix them together, divide them into two, and again some sort of, so homogenization is done, so that your point to point variation of the raw material does not vary too much. So, there some energy goes there as well. So, little bit of processing, even if you do little bit of processing, some energy will go there. first is squaring it out. So, there will be energy, then this will be the energy, this will be transported where they might be crushed, the rocks might be crushed to appropriate sizes, then you prepare the raw feed. So, every stage there is an energy, then you heat it up. So, there is again there is an energy. Now, all this will become part of energy, embodied energy, right, till it is actually put it into the bag or into the truck or what you call bulkers, big vehicles which can transport, pneumatic transport, pneumatically put in there, and they are transported in a large quantity, right, large, even sometimes it is done directly through ships. For example, in India there is a cement factory in Ambujanagar near Gujarat. So, it is in the seashore. So, what they do is directly from the plant it is pneumatically transported to the ship, and this ship travels to the sea to different western coast or even to eastern coast, anywhere they want to supply, like Mumbai, Surat. So, they directly supply there. So, this must be, so basically transportation. So, there is first is the production, once it is bagged or loaded, production is over, then the transportation takes place. So, some energy is consumed on transportation also, right. If the trucks are taking them, the energy that is consumed there. So, this has got a component of production energy, transportation energy, and then there will be another component if you are mixing it with, let us say, mixing with other things, aggregate, etc., etc. So, there is a mixing energy would go in, mixing or production energy of the material system. Now, first is the production energy of the material, component material, transportation, and then production energy for the element or system, right. And if you are transporting it, then again transportation. So, every component of the concrete system you can isolate in this manner, find out their embodied energy of production, embodied energy of transportation, and that is what would fully give you the embodied energy. So, for any material, any system, you can find out the embodied energy, So, that is embodied into it, it has gone into it, right, till you do something about it, after its use you are not able to recover it. Now, some cases during the you have a class? Yeah, during the production process also, during its use also, we might actually use some energy, maintenance. For example, if I am repairing something, right. So, same element that I have produced, I have an embodied energy, and then sometime later on I repair it. So, I again use material, I add embodied energy to it. These are called grey energies because they are not easy to measure. Some might require energy during its useful life also, where like energy is required for its functioning. So, that would become operational energy depending upon, in building this is very clear, building it is extremely clear. So, that is what it is. So, embodied energy is this. So, energy during use, that is what I am saying, the other energy during use, depletion of this is. So, this too we will have to look into when we look at life cycle, and this might lead to depletion of this might lead to material, water and energy depletion may take place, resources might, their depletion might be associated with it. Greenhouse gases production, that is what we should look into, ozone depletion and impact, that is what we should look into, and overall that is what we have looked into so far. So, I think we will continue with that in the next class. From here we will continue and go to more. So, this is kind of an introductory, last previous lecture and this lecture tells you what is sustainability, what are the components you are looking for. So, whenever we are using, either it is a building or even material system, infrastructure or anything, we should look into these issues together, not only the economy, initial economy. Okay? I think that is it. Thank you.